Just one more. Okay. Right, okay, I guess that's it then. Let's get started. Submit that. Pause the beautiful music. Good afternoon, everybody. Welcome back. I hope you're ready to solve some serious problems today. We're just going to be crunching through the numbers. The video is going to be rather short because I don't have a whole lot to say. I'm going to leave you guys to do most of the work. However, I'm not just going to leave you hanging. I'll walk you through the opening of the first three. Okay, I'll give you a couple hints of how to get started. Okay? And that should give you enough, and then we've got the whole period to work. You should be able to easily finish the level 1 problems within the day. And then if you still have time, continue on to the level 2. I've actually picked out the level 2 problems to be a direct extension of one of the level 1 problems. So they really go together quite nicely. So with that, let's dive right in. We're going to start with this triangle guy here. And the problem says, how many equilateral triangles of all sizes are there in a 3 by 3 by 3 equilateral triangle shown next? Here it is. And they give you a reminder here of what an equilateral triangle is. So remember, this is the very beginning of a full geometry text. They haven't formally introduced the definition of equilateral triangle yet. So there's a nice reminder for us. And my hint here is very much like the way we started the example problem from yesterday with draw all of the squares. I would suggest for you to first find, if you're looking for all sizes, figure out what all those sizes look like. So draw out the possible size triangles that you can find in this thing so you know what you're looking for. And then you can kind of have a checklist of, did I find all of these guys? Yep. Did I find all of these guys? Yep. Did I get all these? Right? You work your way down that way. Not too bad. Number 3 introduces possibly a new term. A tetromino is a shape made up of 4 squares where 2 squares are joined along an entire side. You've probably heard of dominoes before, maybe played some games with those. Okay, dominoes, remember, is a rectangle that's made out of 2 squares connected to each other. So a tetromino is 4 squares connected to each other. In fact, it would be really cool to see somebody like make a tetromino set, and then you could have a board game based on that. Or maybe nowadays you can make a video game with a bunch of tetrominos, see if you can fit them all together into nice, neat rows and columns. That's a good idea. Nobody steal that, okay? I'm going to use that. I'm going to get rich off this video game idea. Following tetrominos, it'll be great. Anyways, okay, so if you didn't catch that hint, you can go the old-fashioned way. And I would recommend to try to help organize your thoughts, still draw things out, but start with 1 square, okay? and then continue to add on to that square in various directions. Add one here, then you can turn one there, right? And find out which ways can I add in a square until you get to all 4 squares, right? And create a new shape from there. And this will help you kind of guide and sort them rather than just randomly grabbing, 4 to go this way, 4 that way. Wait, did I do this one already? Is this the same? It really does help if you have a physical piece of paper because you can pick it up and then turn it around and say, oh, yep, that's the same guy but just upside down, right? So that's my hint for you on the tetromino problem. And number 10. Here we have determine if exactly 6 squares of the 3 by 3 grid shown can be shaded so that no 3 shaded squares line up horizontally, vertically, or diagonally. Right? So this is a wonderful chance for you to break out the crayons, and we'll just start coloring in our squares nice and neat. And then, oh shoot, see, this goes 3 in a row. I don't want that. I'm trying to avoid creating a bingo here, so we can't color in that square. So you got to figure out which other squares can I color, right? So you might have a lot of back and forth that way. There's a lot of combinations here. So if that seems like too much, then my hint for you would be instead consider the empty squares. Out of 9 squares total, 6 of them will be colored. That means there's 3 that remain empty, and that's now much more manageable. You can arrange 3 things much easier. In fact, this is the same hint they give in one of the example problems from the draw a picture section having to do something with a milk crate. Let's take a look at that. So back up here in the draw a picture section, they had the example with the painted blocks, but then from the additional problems, there was the square with the diagonals, and then number 2 is a rectangular milk crate, has spaces for 24 bottles, 4 rows, 6 columns. Can you put 18 bottles in the crate so each row and column has an even number of bottles? Right, so this is arranging 18 items inside 24 spaces. Their hint there was instead, consider the spaces do not have bottles. Right? So same kind of scenario. So if you take a look at the strategies for that problem, that might help guide you to a success path for this problem. All right. Any questions there so far? No? All right. Again, level 1 is to complete these 3 problems. If you want to go on to level 2, level 2 starts with a pentomino. Now it's a 5 square shape, right? It's literally the next level up from there. So I thought that was kind of a nice match made right there. So get those first 3 out of the way, and then you can push yourself to go above and beyond if possible. Again, I'm going to leave you the rest of the period to work. Please chime in, ask away if you have any questions or want an additional hint or some guidance on something. I'm happy to help you out. Just let me know. Otherwise, I leave the rest to you.